boys and girls. Today we are going to review our lesson on matter. Okay, so all of you should have spent the first part of science working through this packet. And so now you're going to grade it and we're going to talk about it together. So as I'm doing this, as I'm reading it, going through the answers, you need to make sure that the answers are marked correctly on your packet there. Okay? So, the first question is talking about volume and mass. And remember, we talked about how mass is weight and the volume is how much space it takes up. Okay? And so for this question, I'm going to do an activity. And within that activity, the amount of space that I'm taking up is going to change, but my mass, my weight, is only going to change a little bit. Okay? And so when we're working through this, I'm looking at a soup bowl and I'm filling it up with soup. So as I'm filling up this bowl with soup, my bowl gets heavier and heavier. However, my bowl isn't going to double in size. It's not going to grow bigger all of a sudden. My bowl stays the same. So I automatically am like, A can't be correct. So I'm going to just cross that out. If I'm thinking about a balloon and I'm blowing air into it, my balloon is adding air, and it's as I blow, my volume, the amount of space that balloon takes up. Think about when we had the balloon in the box, it starts to take up space, right? So my volume is increasing. However, my balloon doesn't get super heavy. The mass only changes slightly. So I'm going to say I like that one right now. Thinking about orange juice from a pitcher into a glass. Again, that volume is not changing. Okay? I'm chopping up a wood log into all of these pieces. That doesn't increase my volume. That doesn't increase the amount. Okay? So out of all of these answers, B is going to be the best answer that I can have. So now let's look at number 2. So here's this picture. And on this picture is a ship. And this engineers, they're going to make sure that the ship floats because they don't want it to sink. What is that property? And again, we've talked about properties, right? And we've talked about if something is in water, the property most likely is going to be density. Okay? And the reason why this ship can float on water is because the density of the ship is less than that density of the water. So now we want to move on to number 3. And number 3 is one of those that you need to be able to write what we are calling the short constructed response. You're going to be able to write those 3 to 5 sentences to answer this question. Okay? So we have this wire, and we've tested these before. We've looked at these before. We've seen wires. And we talked about how the wire can be both a conductor and an insulator because the plastic around it is the insulator and the wires inside of it, that copper, that is a conductor. So what you could easily say for your short response is you could say the wire uses both a conductor and an insulator. You're restating your question. Does the wire use a conductor only, an insulator only, or both? So think back to your race strategies that you learned. I'm restating the question. The wire uses both a conductor and an insulator. The conductor is the metal in the center of the wire. It carries electricity. The insulator surrounds the conductor, and it's used to keep the electricity from leaking out of the wire. Boys and girls, that's a perfect response. And if you did that, if you were able to express yourself and write that here, anything similar to that, then you would get full credit. Okay? So now, let's look at number 4. Think about our property of magnetism. So Isaac lowers this horseshoe magnet over a pile of metal paper clips. So these are metal, okay? Then he flips it around, right here. He's flipping it around, and he is now trying to pick up the paper clips. So look at this one right here, and then look at this one, all right? Boys and girls, why is it pulling up here but not here? The answer is because the poles, which are right here, is strongest. When I have my magnet, the force of that magnet is strongest when I have the poles. It's not very strong here. It's hardly going to pick up anything, if not anything at all. Think about your magnetic wands that we have, and how at the top of those wands, when I have my wand like this, the top of my wand is super magnetic, but this wand area here is plastic and it's not magnetic. All right, let's move on to number 5. We've done this experiment. We talked about what was dissolvable and what was not dissolvable, okay? We know out of that if I pour sand into water, it is not soluble. It is not going to dissolve. So automatically, I'm going to cross that out. I also know that if I pour plastic into it, plastic is not going to dissolve. It is not soluble. So I'm going to cross that off. But based off of the testing that we did, based off of our experiments, we know that sugar dissolves in water, and the food dye also dissolves in water. So your answers are going to be B and C for number 5. We're going to move on to question 6. Oh, this is that pot one that we did again. Remember when we talked about how here's my stove and here's my pot on the stove. Why do I not get burned when I touch that handle? Okay? Talking about thermal conductors and thermal insulators, okay? How does a cooking pot use conductors and insulators? You want to choose 2 correct answers for that. Again, we know that C, the metal of the pot, is a thermal conductor, and that's how we can cook food. But I also know that E, the handle, is a thermal insulator, and that's why we don't get hurt. It protects us. Moving on to number 7. Again, we're talking about solubility. We're talking about dissolving in liquid. Okay, so Laura says she mixes a sugar cube into a pitcher of water. Boys and girls, remember we did this experiment on Friday. Okay, so Larissa mixes a sugar cube into a pitcher of water, and as the solution forms, what changes happen to the sugar? Not the water, we're asking about the sugar. What's happening to that sugar? The sugar, boys and girls, is breaking apart. And all of those tiny pieces are spreading throughout the water. Okay? That is creating our solution. These particles are dissolving, they're spreading throughout the water. And now we're having what's like sugar water, almost like, remember how we did it on Friday with, we first had the water, then we did the sugar, and then we added that lemon. Moving on to question 8. This question is going to be a 2-parter. We're going to focus on the first part of it and talking about gases, okay? It's not a solid. It's not a liquid, but it is a gas. And I need to figure out, how can I test that? How do I know that this is going to be a gas? Remember that a gas is going to take on the shape and the volume of whatever container it is. So I could easily squeeze it and I could watch it take on a new shape and volume, because gas takes on whatever shape and whatever container it is in. It takes up that volume and that shape. Part B is another ECR. It's one of those questions that you're going to have to write. So Corey says, hey, sand should be considered a liquid, because if I pour that sand from one container to another, I pour liquids from one container to another, and the sand takes the shape of its container. Do you agree? And explain. We answered this question, boys and girls, a couple of weeks ago in our class discussion. Remember, in order to get the full points, you need to answer both. You need to say, yes, I agree, and then explain, or no, I don't agree, and explain. So an example that you can say is, I disagree. Although a sample of sand can be poured and it looks like it fills its container, the difference is that each individual sand grain never changes. It keeps the same volume. It keeps the same shape. Sand has to be a solid. It cannot be a liquid, because it does not change the shape. The amount of sand might change depending on where it goes, but the individual grains, they don't change their shape. All right, boys and girls, what I want you to do is you are going to, now that all of this is corrected, now that you have all the right answers, I want you to spend the rest of your time in science today working on this part B right here for your question 8. You want to work on part B. So I want you to, based off of what we just shared, I want you to find the words to write complete sentences to make sure that you would get full credit on this. I also want you to go back to question 3, and I want you to do your very best to write it in a way that's going to give you full credit. Answering all the questions, using that race strategy of restating your question, answering the question, citing that evidence, and putting it all together.